Good day, everyone. I'm Gautam. I'm going to present how open data is useful for application development in GIS and remote sensing. So, we have been working on this area for the past 10 years. We've been using open data and open source in delivering our solutions. So, today I'm going to present some of our case studies and e-learning platform where these things can be learned. We currently work on four major domains: water, agriculture, forests, and climate. The approach that we follow in solution development is first we try to know about the challenge, analyze the solution for that, then probably innovate some of the strategies, integrate existing open source into that solution. So we are a stack of solution as information services. We basically use open data to provide these services. We use remote sensing and GIS with open data to perform spatial analysis. And once there is some structure and workflow, we implement some automation and then we develop geospatial decision support systems. So we have three levels of products. One is an enterprise app to actually manage the workflows. Then we have a visualization engine, which we use in delivering the business intelligence applications. And then we have a spatial data processing engine called Dharani, where we use aerial images, satellite data, surveys, or data coming from IoTs. These datasets are processed and then pumped into spatial databases. So this is how we deliver the solutions. So currently we have predominant presence in southern India and slowly expanding to north and northeast India. So we've served more than 4,500 users till now, spread across 20 organizations. We have three types of revenue streams. One is the direct product sales. We also sell processed land use maps or digital elevation models. We also offer consultancy services for designing solutions. This is our team, and we have been in media for different solutions that we have delivered. Let's start our discussion with open data. So, NASA is probably the first organization to host all of its data in open domain. Earth Explorer is the platform where they serve all their datasets. So it's pretty elaborate platform with lots of satellite imagery available for download. Any registered user can get that data downloaded from internet. Then recently, for the past 3-4 years, the European Space Agency, through its Copernicus Open Access Hub, has been allowing users to download their datasets. And then there is digital elevation models also. So this is a collaborative effort from NASA and Japanese entities of remote sensing. And then so there are we primarily use Landsat Sentinel 1 and 2 both, and then we also use digital elevation models in doing feature extraction or any other classifications and generate maps for our users. So say for example in this slide, as you can see, we've tried to extract water bodies, surface water bodies from Landsat and Sentinel datasets. So there are a good number of algorithms available for feature extraction, but we generally used some optimized normalized difference water index to extract these things. I'll explain the process in the next part of the presentation. So when we have these rich datasets, we actually need not depend on any space agency to generate our maps. We can generate these maps by our own. This is one such map that we have generated for a small NGO in Andhra Pradesh. So these kinds of land use maps can be generated from the labs by any research student on their own. So we've been using open data for solution development. If we take geographical information science systems and solutions, science basically is very important in this domain because any solution without science probably will not last long. So we do have teams with good understanding of hydrology, spatiotemporal modeling, or any other such domains. And then we build solutions based on this science, and then we have systems which are part of these solutions where open source tools are very important. So one such system that we built is being used by Telangana government for the past 4-5 years in managing all their minor irrigation assets. I'll explain that case study as well. What we have been trying with OSGeo India is to build a participatory GIS model. So we call this as data democratization, where actually students or volunteers, we plan to build a platform where people can register themselves, access open data, and then learn how to process it, and then actually process the data and then publish it on that platform. There'll be users who are interested to use that data. It could be irrigation departments, electricity departments, urban planners, anyone like that. Whoever uses that data will be paying for that data. So we are trying to build this kind of model where there's learning happening, and as well as some business happening, so that this model is self-sustainable in the long run. So recently we've presented this idea to Atal Innovation Center in IIIT Hyderabad, and they have agreed to incubate this idea in AIC. So we started just 2 months back. So we'll be building this model over a period of 2-3 years down the line. Of participatory GIS is an education platform. So in this context, we've developed something called SEED. SEED is Smart Education Using Earth Data. So the idea is to have all the education content in this platform, and then slowly encourage users to learn from this platform and then build their own applications and solutions as a open data and open source effort. Okay. So we are focusing currently on environment related issues. So as per UNSDG 15, there is a global policy to protect the forests and improve the sustainable practices. And India also, there is environment education that is being made mandatory to all young researchers and young students in the colleges. So there is a clear guidance from either global entities or Indian government that environment education has to be emphasized at young ages. So why should we have environment education? So as we can see, there's lots of changes happening all over the world because of climate change. There are extreme weather conditions. If we take Jammu and Kashmir, melting glaciers is a big issue which may affect the local environment. In other parts of India, it could be droughts, it could be floods that are affecting. Even Srinagar, we had floods some 3-4 years back. So these will have socio-economic impact. So if there are droughts in arid areas, especially, women have to spend more time in fetching water for the households. So that increases dropouts in in schools. So that's those kinds of effects that climate change has. So the solution for addressing climate change is to increase the awareness among citizens. So satellite data helps in monitoring climate changes and managing natural resources effectively. So we are trying to build this technology stack where people use satellite data to actually monitor climate changes and manage their local natural resources. So we are planning to start with Ramsar sites in India and then slowly move to Western Ghats and other Himalayan foothills as we go by. So in the current scenario, there are educational institutions doing a lot of research activities. There are several organizations, could be under ministry or could be NGOs working on climate change, and there are geospatial service providers. So there is a need to bring them all together so that there are more jobs created in environment domain, and then there are people who have that knowledge working with these organizations bring in more impact and conserve the environment. So we are trying to present seed in this context to encourage people to learn usage of satellite data. So after its complete development, this seed will have these components. So they'll have data repositories, they'll have interfaces to learn something, and then each individual will have their own workspace where they can experiment online, and then they can seek either help from their colleagues in the platform, or they can seek help from some mentors, and they can also evaluate their learning on the platform itself. Then once we have this seed operational, there'll be extension to this where we are trying to build a simulation-based learning platform. So the workspace that we've talked here will be something like this. There'll be data in the platform, and the people who are learning will bring in their own domain expertise. So they build rule-based models on the platform, and then they'll try to apply those rules and models onto certain applications, and then help people take some decisions, or they'll create decision stacks by themselves, and then that analysis or results are presented to wider public through the same platform. So this will be the complete layer stack that we'll have. So there will be data, there will be domain expertise, there will be application development, there will be presentation of the content to the citizens and stakeholders. So we'll be using these open source tools at each level. So for data, we are using GeoTools. For domain, we use PostgreSQL and PostGIS. So for servers, we use GeoServer, Cache kind of thing. And then for presentations, we use OpenLayers. So this is the product that we are talking about. So it has a good interface with certain lessons currently. So there are video tutorials, there are ebooks, and there is online learning. So I'll show a demo of this. So this is the website where you can go and register and you start using this. So we are trying to provide employment opportunities, link this to employment opportunities with our collaborators and clients. So there is a video library, a YouTube channel with all the individual lessons, like how to use QGIS. They're mostly based out of QGIS currently. How to use them in doing certain sets of analysis. And then there are ebooks. So they are in Kindle. So those who want to read these things offline, they can go and then purchase these books and then start reading it. So, but online, it's there's no charge. You can directly go and start reading. So, for example, this is how the lessons are structured. So currently we have three parts. So one for Landsat, one for Sentinel, and then one for Modis currently. So this is completely interactive. So the map scales to certain place, and then you'll be able to see the changes. You can see different how this two color image looks in different bands. So here we have blue, green, and red, and then how it was in 2013. So we can see the change. So this kind of interactive learning helps to understand satellite data when fitted into a particular context. So this is about Landsat. We also have simple tools to measure areas and measure lengths. So these kinds of things are there. So there is also lesson about Sentinel. So the bands and then why each band is used. So how it can help in tree canopy. So you can see tree canopy here. So Sentinel has one extra band, which is red edge band in between visual spectrum and infrared. So these bands are useful for actually crop monitoring. So it has an added advantage when compared to Landsat, and resolution is also pretty good. And coming to Modis has web service based data access, and its temporal resolution is pretty high. So some of them, say for example, land surface temperature, we get anywhere between 3 to 4 samples in a day. So if you can see here, this is land surface temperature. So all these areas which are in lighter shades have lesser temperature, and urban areas have predominantly higher temperatures. So probably LST can be used to actually classify urban areas or find out urban heat islands using the Modis data. And then there is self-assessment that is there. So you can, once there is enough learning, a person can go here and then start evaluating. And then there are video tutorials that we have seen earlier. So they are embedded into this platform. So if apart from reading the theory, users can go and then experiment these things in their labs, and then probably do some extensive research. And then there are books, same books embedded here. And then if there is some help needed, you can always contact through this platform. So we are trying to integrate this with something like Quora or Google Forums, so that there will be much more interaction. So in coming days we'll have that kind of a thing. That is the reason we have linked this with Google ID, so that there can be existing things can be used and integrated into this platform. So this is about the platform. And then coming back to our presentation, so we've done till now we've been doing offline workshops, both to government and citizen groups. So we've trained. So there are two major projects that we have done with respect to trainings. So as part of lake management in Telangana districts, we have trained more than 200 engineers, and as part of our Western Ghats project, we have trained more than 600 researchers in all the 6 states of Western Ghats, from Gujarat to Kerala. So this is what we are planning to roll out phase by phase over the next 8 years. So currently we have e-learning platform, and then we want to include datasets of 37 Ramsar sites, and then we want to encourage people to build services and apps on this platform and then slowly spread to Western Ghats and Himalayan foothills. Then, as the product goes into gamification and simulation based learning, we want to expand our reach to arid regions of India as well. So, if you have any questions regarding this platform, you can always mail us at seed@kaiinos.com. You can visit the website at seed.kaiinos.com. Thank you. In some online platform where we can learn about open data. Now, why do we need open data? What are the applications where we can use open data and do some analysis? So, in this section, we'll see that. So, say for example, we have this image from Landsat and say we want to extract these water bodies. As we can see, there are some water bodies here. So, there are some tools or indexes. So, NDWA is one such index where we have we take a combination of different spectral bands and then generate this kind of an image, okay, by using mathematical normalization. But as we can see, the normal NDWA results in shadows as well. Shadows also are shown as have the same response as water bodies. So how do we eliminate these shadows that we are able to see here and distinguish? So because there is a lot of data available in open domain, it allows us to actually experiment a lot on these kinds of things. So if we are purchasing some data, probably we may have a limited scope for experimentation because NASA and European Space Agency are providing us a lot of open data as these missions are from taxpayers' money. These are kept open, both open and free for anyone to use all around the world. Okay. So now coming back to this analysis. So we have improved the NDWA by using a convolution of all the bands between 5 and 7 in Landsat. So by doing this, as it can be seen here, there's a clear distinction between shadows and water bodies. Now we use simple thresholding on this kind of image to generate the vectors. So now this will be the output of the vectorized water bodies. So now why should we extract these water bodies? Where are these kinds of things used? Say for example, we do these kinds of watershed delineation and check the changes that happen, say every month. Then this kind of analysis of extracting the amount of water that is present helps in budgeting the water and then planning the crops based on the availability of water. So this is a very important application given the context of India and the load that we have on natural resources. So there are other applications like if we have these kinds of platforms where we generate data every month or every 15 days, then that can be used to visualize things like this and then see whether we have enough water in a given landscape or there is a drought kind of a situation. So as it can be seen here, we have varied amounts of water and a proportional amount of vegetation. All red that we see here is vegetation, and as we can see, as water increases, there is increase in vegetation. As water is decreasing, it's more like a drought kind of a situation. Apart from water and agriculture, we can also use open data to monitor the spread of urban areas. As this can be seen here, say for example, Sentinel satellite data comes every five days. If there is some cloud, probably every 10 days we will be able to download the data and process it. Say if we have as we have this data available, we can use built-up indexes. It could be IBI, it could be BBI, it could be NDBI. We'll be able to extract the changes that happen in the urban landscapes. Given the demographics of India, there will be some construction happening every day. So it is very useful to monitor these things remotely. If there is a change, then probably municipal authorities can go to field and then monitor that change. So if there is a system which can monitor and uh, alert the municipal authorities about the changes, then it will be easier for audit and tax collection. So that improves the revenues and reduces the burden on the environment by avoiding illegal constructions, which is very rampant in India. With Sentinel satellite data, we can even go to the level of a building by using feature enhancement. So as you can see here, there is one building here. So if we want to extract the dimensions of that building, we can do simple edge detection and then extract the building footprint. And then probably we have to improvise this image. We can do that improvisation also using regular Gaussian based edge detection techniques. So Sentinel is good enough for any urban application, but Landsat might not be this good because Landsat is 30 meter resolution. Sentinel is 10 meter resolution. Any big building or big change can be visualized using Sentinel data. And coming to other applications, say we have to, as in the last section, we've seen MODIS land surface temperature, where we have seen pretty good difference between urban and rural landscapes. So if we have to compare or get this kind of data, say every day, MODIS land surface temperature, MODIS has two satellites in its repository. So we get at least 4 recordings of land surface temperature every day. Even if we get one, that would be good enough for measuring crop health or something like that. But then MODIS spatial, though the temporal resolution is very good, spatial resolution is 1 kilometer. So now we are trying to actually bring it down to 30 meter resolution using Landsat data. So Landsat and MODIS have similar thermal sensors. So we have used these two satellites to bring down spatial resolution of MODIS to Landsat by using resampling, different downsampling techniques. So we have tried 4 techniques. One is inverse distance weights, linear regression, polynomial regression, grid-based linear regression. So with inverse distance weights, we got RMSE of plus or minus 7, but with the grid-based linear regression, it was plus or minus 2. So grid-based was actually really good, where the predictions and the actual data was really accurate. So plus or minus 2 for crop health detection might be good enough. Say, because we have a lot of data coming every day, so that would help actually. Every hectare will get at least 10 to 15 samples. So that's a good sampling rate to estimate any crop health based on land surface temperature. MODIS also has products for vegetation index and then evapotranspiration. Even they can be downsampled like this, and then we'll have a good parameter list to actually measure the crop health and probably predict the yield. So we are still in that process. So that way, open data is really useful in many large scale applications like that. Now, say this is the output of this simulation. So one of them, as you can, the image on the left side is a simulated image. It's not a real image. This is the real image. So we took MODIS and then simulated the 30 meter resolution data, and then this is the real image. As you can see, for human eye, they are almost same. So as we have marked the differences here, only these parts there is some difference. Otherwise, they are pretty same. So the artificial intelligence works really well in this context because this is a simple, straightforward simulation. So We've seen water, we've seen vegetation, we've seen urban applications, and we've seen surface temperature related applications. Even digital elevation data is also available in open domain uh, for at 30-meter resolution for free. Higher resolutions are also available from JAXA. They're really good. We've used them in Madhya Pradesh in some irrigation projects. And we have also used open data for large scale watershed planning kind of thing. So depending on the scale, we use different resolutions. So if we take this digital elevation model, we've generated streams, and we've used this in Telangana to actually rank the water bodies based on the size of the sink that they are in. So that helps in planning for different water harvesting strategies in arid regions of India. So we also, once we have this kind of watershed delineation done, so the land use can be overlaid on these things, and then different planning like afforestation or crop planning can be done based on the water availability. So these strategies will be using in Madhya Pradesh, Telangana, and Andhra Pradesh till now. I'll show some case studies. Applications that are built. So this is one such application where we have used open data from Sentinel to do the crop monitoring. So, and this application is built using OpenLayers and GeoServer. So OpenLayers has very good list of tutorials to build these kinds of interfaces. We've done this in collaboration with ICRISAT for Chhattisgarh government. So the data is published here, and there are, as you can see, there are filters available, and there is season here. So there are multi-season variants. We'll be able to see, but all of these are single seasons. Yeah, here we have another season. So this season is 2019. There are more crops here. So this is one application, comprehensive enterprise system kind of thing. So there are seven classes or 11 classes based on the end user's need, and we have these kinds of WMS integration as well in this platform. So in collaboration with OSGeo India, we have done biodiversity spatial data infrastructure for Western Ghats, where we have published all the data collected from crowdsourced sources, and then we have published them as web services, which can be accessed on desktop. Source code is available in GitLab, and then all these things are built using OGC standard, so there is interoperability. We have conducted different workshops in 61 districts with representatives from 61 districts across 6 states, so that people can use this data and then do the research and publish some articles. So these are the components. So there's reading materials available, and then there are data sources available here, and then there's source code available here, which can be accessed and tried. So these are the people who have collaborated in this effort. So we are trying to expand this platform into a bigger one with Seed as online e-learning platform, and then enable people to publish their own datasets and their own apps based on this framework of open data and OGC standards. So what kind of applications can we build? Say for example, we have done this for a NGO. So they were doing some afforestation in these areas. So in 1992 it was like this. In 2005 these areas there was some change. and 2015, as we can see, the dense vegetation has increased. So this kind of a thing um, helps people to actually showcase their efforts uh, to any of their stakeholders. It could be funders, it could be citizens, it could be people living in these areas, and then they can show them that their efforts have been really fruitful, and then there's a lot of work that can be done in similar lines. So in this landscape itself, we have a lot of area again to be regenerated. So these are the applications, some of the applications that we can think of using open data, and see it can play a role uh, in making people use open data and improve the sustainability in the region.